Welcome to RLC MATLAB Academy. Today we are going to discuss about solar PV system with Fuzzy MPPT. This is the structure of solar PV system with Fuzzy MPPT. In this is the solar PV array. The input is irradiance and temperature. We have selected constant irradiance and variable irradiance, and temperature is 25 degrees Celsius. Next, the output of PV array is given to the boost converter. This is boost converter. This is boost converter. Boost converter consists of two capacitors, one inductor, and one IGBT and diode. This is the load resistance. In this boost converter, the gate pulse is given from the PWM generator. To extract the maximum power from the PV array, we need to use Fuzzy MPPT here. In this previous video, we have studied about PO MPPT. Now we are studying about Fuzzy MPPT. This is the Fuzzy MPPT. The Fuzzy MPPT output is duty cycle, input is VPV in and IPV. The duty cycle provide to the PWM generator. PWM generator will provide the gate pulse for the boost converter to extract the maximum power from the PV panel. This is the power from the PV panel is given to the bus selector. This bus selector output is VPV and IPV. This is given to the Fuzzy MPPT. This is the scope for PV panel. This is the scope for load side. This is the PV array. Now we are going to select the PV array rating. I'm going to double click this one. The same rating we have used in the PO MPPT. We have select the PVIV characteristics. Here we have used 1 parallel string and 4 series string. Now I am going to plot the characteristics. Now you can check the output power of the PV panel. This is the output power of the PV panel. That is maximum 1.2 kilowatt. This is the maximum voltage and current. So 151 volt, 8.38 amps current. This is we need to check the characteristics in the graph while running the simulation. Based on this rating, we need to design the boost converter calculation, that is L, C and R values based on this, and duty cycle values. Based on the PV array, we need to fix the capacitor and inductors and resistor and duty cycle values. Based on that, we need to write the Fuzzy MPPT. This is the Fuzzy MPPT we used here. These are the Fuzzy MPPT system. This is the Fuzzy Logic controller. Already we have loaded the Fuzzy file. How to use this Fuzzy file means we need to go to the workspace and type Fuzzy Logic Designer. So you need to type Fuzzy Logic Designer. This is the old version of the Fuzzy Logic Designer. Or else if you need new one, you need to type the Fuzzy Logic Designer. This is the new one. You can choose any one of the system. This is the old one. This is the new one. If you want to use new rule, click custom sys. In that you need to type number of inputs. I have used 2 input and 1 output. Now I am going to click OK. This is the 2 input. You can click this one and change the name. First one is error, second one is change of error. You can select the name like this. Output is duty cycle. This is the MPPT techniques used in the Fuzzy system. So now you have to add the rules. First you have to select the error. You need to select the membership function by clicking this one. So you can use this one. I have used 7 membership functions. Positive big, positive medium, positive small and 0, negative big, negative small and negative medium. Like that I have chosen 7 input number of membership function for error and change of error. Then you have to fix the range. Duty cycle we need to fix 0 to 1 only. So you can select the range for each membership function, error and change of error. Based on that, you have to select the type. You need to type, you need to enter triangular or trapezoidal, whatever you need, you have to select, and based on the range, we need to enter the details parameters also. You have to fix these 3 details: error, change of error and duty cycle. Based on that, we have to enter the rules. We need to add the rule. This is 7. This is 7 means we need to enter 49 rules. If you need, you can reduce the number of rules. For 5 means you need to enter the 25 rules. You have to add 25 rules. For example, you have to we will select view in ruler. You can select this one. If you are selecting this one means first one in error MF1, this is MF1, C is MF1, or you can change MF2, then D is MF1. Like that you have to select, or else you can change the, for example, I'm going to, this is the error, this is error, this is change of error, wait 1 minute, this is error, this is change of error, this is rule based system, this is output, this is error, this is change of error, this is rule based system, this is output duty cycle. Here we are using 7 rules. What are the rules means? First, negative, big, negative, medium, negative, small, 0, positive, small, positive, medium, positive, big. These are the 7 rules. These 7 rules used for this one, and this one. These 7 rules we need to enter. These 7 rules included in this one, and this one. Based on that, you have to add the rule. First one, error is NB and change of error is NB. Now, duty cycle is, you have to select NB or whatever you need. You have to select like this. Next, error is NM and change of error is NB. You have to fix for 7 rules NB itself, and duty cycle is NM. You can select whatever you need. The same rule, we need not to repeat the 49. That is the concept. Next error is third one, NS, and change of error is NB. This NB will fixed for 7. With respect to NB, NM, NS, 0, positive, small, PS, PM, PB. You can change like this one. These are the 7 rules. According to that second set, E is NB and C, change of error is, here you have selected all NB. Now you can change with NM and select D is NB, NM, like that. You have to set or add this 7 into 7, 49 rules. This is the selection of error and change of error. Based on that, you have to select C is MF1. MF1 means that is NB. This is N. You have to select NB. Like that you can add. Now you can select the second one, that is MF2. You can select as it is MF1. This is NB. You can select this one MF2. The rule 2 is changed. Like that you have to change everything and save this file as FLC or anything. This file you need to save. This is the concept for fuzzy logic system. Already I have saved. This is the old one. In this also you have to select this new fuzz. Anyone you can choose. You have to add the input. You have to edit and add variable. Input is 2. Input is 2. Output is 1. You have to select the input name is error and change of error. This is output is duty cycle. Like that you have to enter all details. Okay. You have to select this one. Double click one. First one. You have to select, for example, first you have to select the trapezoidal, means you can select the trapezoidal. You have to enter 4 values for trapezoidal function. Trapezoidal means you have to enter 4 values. So the trapezoidal is 4. Triangular means you have to enter 3 values. 1, 2, 3 values. This is 1, 2, 3, 4 values. You need to enter 4 values for trapezoidal and 3 values for triangular function. If you are, I am selecting triangular means this will be have 3 details. This is 1, 0 and this one. And you need to select the ranges. Output is duty cycle 0 to 1. This is the range. You have to enter the same details. Error 5 means this one, this error also 5 and output also 5. 5 rules, 5 into 5, 25 rules. Or 7 means 7, 7, 7. 7 sevens are 49. 49 rules you need to add. You have to add the sys file and load in the fuzzy logic toolbox. Inside this, you need to add this fuzzy MPPT. The fuzzy MPPT output will be duty cycle. Duty cycle given to the PWM generator, and PWM generator produce the PWM pulse. The pulse is given to the IGBT to trigger the gate pulse. The boost converter boosts the voltage and you can check the output in the scope. Now I am going to run the simulation. I am going to run. Now you can check the graph. This is connected into the variable irradiance. You can check the system. This is the output and This is the input side. You can check the values, PV power and load power. We have fixed the PV power is 1.2 kilowatts, that is 1200. You can check the PV power, input PV power is almost 1000. We can check it. This is 1200, and this one we can check 1150, like that, 1100 approximately. Output is 1100. This is 1200. You can now calculate the efficiency. Surely there will be some converter loss. We are using boost converter, switching loss and converter loss will be there. We surely will get the output power will be less than the input power, so that we can calculate the efficiency for load power versus output power. Sorry, input power. Thank you. Thank you for watching our videos. Kindly subscribe for getting more MATLAB models. Thank you.